struct or class, they are a way to encapsulate, to put things together, right? Put many of the variables together. We have learned that, such as vectors, but vectors only applies to data with the same type. But for structure and classes, we are trying to group things that are from different type, maybe different meanings, right? Group them together so that they will form an individual object. So that is our goal. So struct is indeed proposed in the C language. So in the C language, if you use struct, it can still work. But for class, it's only for C++, right? So, but the struct in C and C++, there will be a little bit difference because in C++, struct and a class are basically identical. You will see one example later. So the reason we say we want a class is because we want to define our own type, right? For instance, in the old days, we have arrays, but somehow we want to define a class called a vector, right? Why do we define a class called a vector? For instance, if you are using array, if you want to pass it to some functions, not only you need the address, right? You also need the size as a parameter to pass into a function together. And because these two variables are actually independent, right? You can change your array address, you can change your size in any way. But if you want to encapsulate them into just one object, maybe just call it a vector, right? Then you pass this vector. So the outside cannot simply modify your size, right? The only way they can do is push in out data, right? Pop out data, get the size. They cannot do arbitrary things to the element inside your class. So that's our goal. And another benefit is we want to separate the interface and implementations, right? Still use the vector as an example. If we want to call vector.pushback, right? We don't care about how our library implements this pushback. It doesn't change. This class can still be used, right? Our code don't need to be changed. So that is, we want to separate interface and the real implementation. Also, when we are writing our code, we want to separate them. So the most important concept you need to understand is called encapsulation, right? Encapsulate the data inside our class and it controls who can access which element. So that is our basic goal. When we are talking about the variables, right? When we talk about arrays, we said array address and size. These two are basically relative variables, right? These two are related. They should belong to someone. So if we are trying to define a number of relative variables together and making them independent variables, sometimes we will have some issues. So using this one as an example, assuming we have a something to describe our computer products or electronic products. It contains, for instance, name, price, and a score, right? So maybe how fast your computer can run, right? Typically, we get the score by running a benchmark. So assuming these are the properties of our product. For instance, when we want to compare two products, right? We say, how about we define the metric as the score per price, right? For every dollar, what is the performance you can get? We use this one as our metric and compare two products. And we are trying to find out who is the best product, right? So assuming this is the one, and we can write some code like this. First, we define a few variables, right? Define the default one. The best product, its name is empty. The price is 1,000. The score is 0. Because for every machine, the score is at least a positive number. So this one would be the worst product, right? And then it's a while loop, infinite while loop. And we can define the next product you are trying to input. Define the name, define the price, define the score, ask the user to see in it, right? And if the name is a pound or hash, we say, okay, it's the end of the input, which is the sentinel, right? And if the next product is a score score per price is better than current best score per price, then we are assigning the current one, right, to the best product. So these are the basic steps. And finally, we are trying to output it, right? I put everything in the function and I call it in my main function. So let's run it. For example, the first product A, the price 100 and score 1. Next product B, price 200, score 3. And we want to end with a hash. So we can output the best product, right? It's defined by the score divided by the price. So as you can see, this one, right? It's a metric. It's a metric. We define who is better. Let's call this one a function. Let me see if we have the function defined. This is the code we write, and let's define a function that is comparing two products. This is the one. Wait a minute. Is it in Chinese? Yes. All right. So let's copy it there. So this is the function that is comparing the next product versus the best product, right? It's indeed comparing four numbers. These four numbers can be anything. They're independent variables. And we are returning comparing, right? This one, score divided by price, is it greater than the score divided by price, right? So it will return either true or false, right? Return a Boolean. So now we can use this function here. This function is in here. And we make them the parameters. Right? Now the code and the previous code are exactly the same, right? So as you can see, in this function here, we are expecting the user to use this function properly. They are putting the next score in the first place, next price in the second place, best score in the third place, and the best price in the last place, right? We are expecting the user to use it properly. And then we are expecting the programmer to give it a good name, right? Otherwise, if it's A, B, C, and a D, right, it will be very hard to for others to read your code. They will not be able to understand what you are doing, right, in here. So it's very hard to understand it. That's why we are introducing the structure, or in the very old C style, we are introducing the structure. So how can we define a structure? For instance, we are trying to define a structure called a product, and we need a semicolon here. We are trying to group a few related variables together. We are trying to group them together like this. And let's call it a name. It's a type definition. So this is a type. We are defining a type called a product. It contains things. First one, name. Second one, price. Last one, score. As you can see, this one is similar to vectors, right? It contains all the elements. It contains three parts. It contains, but the difference is the type could be different. If it's a vector, everything should be the same type. But here I can have different type. First one, string. Second one, double. Last one, int, right? We can have different types for a structure. And this product from now on can be just a type, right? Any place type could be, product could be there. So let's use this one here. It's called best. Let me keep this one. Let's call it product, best product. Because product is a type, we can define its variable like this, right? The type, the variable name. The type, the variable name. Similar, double is a type, best price is a variable name, right? We are defining a best product, which is a type product. So this is let me call it, this is a C++ style. This is a C++ style because in C++, struct are the same as class. We will see later. But in the old C style, you should see some code like this. best product. This is the C style, right? So both of them are valid, but I would prefer the C++ style, right? So in the old C style, you have to put struct and the name together so that it can specify this one is a type. And also in the old C style, you would see someone writing code like this, type define. They're trying to defining a type, then call it a product type, right? Something like this. And using the product type to define something in the future. But forget about it. If you see it, you can search online. What does it mean? But basically, it's just from very old styles, right? So we are using it in this way, defining a variable which belongs to the type of product. And now, as you can see, this one contains 3 parts. We call them members. It contains 3 members. First one is called a name. Next one is a price. Next one is a score. So we could use it as, let me see, how can I quickly change it? Let me, is there any way to add it all? Yeah. Wait a minute, I cannot do it. Let me add it all. All right, so call it best product dot name. Is it done? Best, no, it's not changing. Wait, yeah, it's changing, right? Best product dot name, good. Let me continue. Best product dot name, change this one. Best product dot price, changing this one. Best product dot score. All right, so this is how we can access the members of a structure. It should be similar, right? You have a function such as if we define a vector dot size, right? This dot and this dot are exactly the same. They are the members of the structure or class. So you should be familiar with this dot. It basically says, I want to access the element inside of this variable, right? It's a structure. It contains 3 parts. You want to access each part one by one, right? This is using the dot operation. This is called a dot operation. So after this one, you can also define your next product. Right? You can define your next product. This one, next product. Next name, let me change that. Control, replace it with next product dot name. Replace all. Yeah, maybe just replace. All right, this is the first one. Then yeah, it's too much. Let me delete this part, and yeah, just do it manually. Dot price dot score, right? Similar to this way, right? I can see into it because I define the next product. I can see into its members, name, price, and the score. And if the name is pound or hash, we just break. And instead of writing this part in this way, indeed, we are trying to compare next product versus best product. If it's better than the current best product, what we're trying to do is, no, we are trying to assign the next product to your current best product. So that is something we are trying to do. All right, let me go here and call this function. It's a product, all right? You have your next product and a product, which is your current best product. You're returning this one. It should be next product dot score divided by next product dot price divided by best product dot score divided by best product dot price. All right. So as you can see, we are almost doing exactly the same, right? The only difference is I'm using structure to group some of the related variables together. But what's the benefit? First, the benefit is if you compare these two functions, right? Compare these two functions. Let me use the same name. If you compare these two functions, right? The second one apparently has better readability. The first one says, okay, my function takes 4 numbers. I don't know what's the relationship between them, right? But the second one says, I'm taking 2 products. I'm comparing 2 products. The idea is this function itself, it already tells you something, right? Is the product better than the other product? By reading the first line, we basically can guess what is the programmer want to do. So that is a better way in here. Second one is instead of copying them manually, right? Sometimes it's tedious and you will have some errors in the middle. But here, if you read these 2 lines, right? It's very easy to understand. You are comparing next product with the current best one. If next product is better than current best one, you just assign your next product to your current best. So that's the benefit of group things together, right? You are giving it some meaningful name, such as product, and you are trying to group related things together. So you are reducing the number of errors, and you are making your code more readable. So that is the main benefits in here. All right, let me see how can I change it. All right, so yeah, I just copy this code to Canvas so that because I will modify it. Let's see here. And I replied to it. Yeah, you guys can check. All right, so this one is product structure, right? We said we also talk about a class. How about we define a class in it? All right, so in C++, structure and class are basically the same. The only difference is structure make every member public. Class make every member private. Make every member private. So if you want to change, for instance, if I'm trying to implement a function called is better than, instead of this called product class, you will get some errors. The errors tells you price is a private member of your product class, right? This is our product class. It seems exactly the same as the structure class, right? They are identical. The only difference is if you are trying to access its member, it's private. But if you are trying to access the member of a structure, it's public. So everyone can access its member. It's called access control. So very important idea is access control. So in here, it's very similar to put something called a public here. Here, indeed, everything is private. So that's their difference. So if I make this one public, if I specifically saying this guy are public, now this class and this structure are exactly the same. They are exactly the same. And as you can see, there will be no errors here. There will be no errors here, right? And you can use every place when you use a structure, you use a structure class. No, the product class, right? They are exactly the same. You have no issues. Let's run it and see if it can work. 101 B 203 hash, right? It can also work. So these two are exactly the same. And these two are exactly the same. This class and this structure are exactly the same. If I make every member of your struct to be private, then these two are exactly the same. But if I make it private, it means no one outside of my structure could access it. There will be some errors in here, right? Remember, the product is a structure. If I make the score a private member, you cannot access it because you are outside of your structure. So that's the only difference between structure and the class. We have another thing is called, let me make this one back. Public. We have another structure called a union. Union is a little bit different. Let me see, how can I show it? Yeah, let me go to the slides. Let's see what it's doing here. All right, so structure is a way to group some of the related variables. Whether they are related, it depends on the designer, right? Who is designing the program. They think these variables are related, then they are related. Right? If you think they are related, you could group them in one place. And each variable, we call it a member of the structure. And we need the semicolon at the end. Right? Sometimes it seems weird, right? If you are defining a function at the end of the brace, you don't need a semicolon. But if you are defining a class or structure, you need a semicolon at the end. If you forget about it, the compiler will complain. And when you define a structure like this, the name product itself from now on is a type, right? You could say a factor of product, right? In the past, we know a factor of integer. Now we can have a factor of product. You can do that. And it can be used to define as many data as you want. And you can access them, right, using a dot operation. So here is the code we just show. And here is the way, right? We are comparing indeed two products. And because it's a type, we could also use the constant reference because it contains more than one variables, right? Sometimes we want to save some space, we use the reference. And the first const means we don't want to modify the next product. So that is the way you can do. So there are a few things in C++. We have compared these two, right? If it's a structure, the default access control is public. Everyone could access my members. If it's a class, if you don't specify they are public, then every data is private. No one can access my data. No one can access my data. And both of them, they contains all the members. But if it's a union, it's public, but it only contains one member. All right, so the structure and the union are introduced in the C language. So sometimes it's a little bit complex to understand, but they indeed, when they design it, they don't have the access control. So everything is public, right? As you can see, struct and union, everything is public. Their only difference is union contains only one member. So it means union can save some space. If you don't need all of them, you can save some space. It only contains one member, but a structure contains all the members. So let me give you an example showing you what is difference between union and this. Let me see, should I keep it? Anyway, let's put it here. Call it struct test. Let's have a long called int value, and let's have a double called a double value. All right, semicolon. Let me have a union, and call it union test. Let's first output the size. All right, we have learned something called size of structure test, and let's output the union test. Let's see what will happen. As you can see, the structure test contains 16 bytes, because long is 8 bytes, double is 8 bytes, right? But for union test, it only contains 8 bytes because it only contains one element. It's not two, it's just one element. So if you are trying to assign, for instance, let this one be smaller so we will be able to see. Structure test, that's called T1, and the union test called T2. For T1, if you assign int v to 10 and T1 double v to 1.1, right? Let's see out the whole line, copy it there. T1 dot int value, then T1 dot double value. We can do the same for the union. Yeah, it should be union T2, right? T2, 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 and T2. Let's run it. So as you can see, the first guy is T1.int v is 10, T1.double v is 1.1, right? Second one, T2.int v is some weird number, T2.double v is 1.1, right? So the reason of this one is, if you look at the structure, right? If I'm defining, if it's a structure, if I'm defining a long and a double, the int and the double, right? They will be in different places. They will be in different places. It contains all the elements. First one, int value. Second one, double value, right? This is your data. And the int value can point to here, double value pointed to here. They have different space. If they have different space in your memory, but if it's a union only contains one element. What does it mean? It only contains one storage space. It only contains one storage space for your data. So your int v is here. Your double v is also here. They are pointing to the same place of your memory. So the first one, you're assigning 10 to here, assigning 1.1 to here. So when you read it, it's still 10 and 1.1. The second one, if you assign 10 here, 10 will be here. Then if you assign 1.1 here, this one is erased to be 1.1. But this 1.1 will be encoded using a double because it's a double. If it's a double, it's 64 bytes and it follows the IEEE format. There will be a bunch of, for example, 0, 1s, 0, 1s, right? You can interpret this one as a double. You could also interpret it as an integer, right? So that is the basic idea about union. So in the old C days, at that time, the memory is very limited. So that's why when you don't need two values, right? If in some case, there will be only one of them is valid, then you don't want to waste some space in here. So that is in the very old days when memory is very limited. But nowadays, people tend to forget about what is a union, right? But in some of the code, you might still see them. So also let's make more tests, right? As you can see here is this way, but how about we reverse this order, right? How about we reverse this order? Then this int v is 10, right? Because if you encode it in as long, it's correct. But if you view the 10 as a double, it will be interpreted using the IEEE format, then it will be interpreted as some weird number, right? So anyway, it's basically says for union, it only contains one member. It doesn't mean it's just a one member, right? It means they pointing to the same location. You can think of that way. how about if I have a string here, right? If I have a string here, it will compute the largest size. It will compute the largest size, and this size is the final size for the whole union. If this one, if a char c, if a int k, right? You can still see the construct for, anyway, it's a construct issues because of the string. All right, you can have this. As you can see, the size of your union test is still 8. It didn't change because the largest size is the double and the long, right? They are 8 bytes. For character and integer, they are only maybe the first one maybe 1 byte, the second one maybe 4 bytes. So they're still pointing to the same part. They are trying to reuse the space. They're trying to reuse the space for long, for double, for character, for int, right? You can put as many as you want, but there's only one of them might be a correct value, right? But you can still print them. You can still print it. You can still print it t2.c. You can still print it. Might not be good enough. It may be some empty space printed here. You never know. Let's put some numbers so that it's easy to see. It's k, right? It comes 10 because long and int, if you look at how they are encoded, they are quite similar to each other. So anyway, the reason I introduced union because of in some of the code you might encounter them and you are asking why do they use union? What's the meaning of union, right? You can look at it, but the thing is, in the past maybe 10 years or more, I never used the union in my project. All right, I never used the union in my project because the machines are more powerful. We have hundreds of gigabytes of memory. Why should I care about saving a few bytes, right? It doesn't make sense. You are making the other people confusing. So nowadays, the space doesn't mean anything. Just use the structure, right? Even if you are wasting some space, it doesn't matter. So that is the union. So in the old day, how people typically use it is, for example, if I have a sample, it is either integer or double. It is either integer or double, but you don't know. You're asking the user to give you, or you are trying to output it. Then you can have some enum, right? Some enum to specify what is the type. This int v and a double t don't have any meaning, right? It's just the name for your enum. It could be A and B, right? It could be anything. And when you are trying to use it, typically people use a enum so that you can specify what is the type. And based on the type, you can, for example, if it's this enum, you output the integer. If it's this enum, you output this double, right? This is the old way people typically use. Yeah, just know this one is enough for unions. And also someone asked me why we never used the enum before, right? Because in most of the code you don't need, but for this code, you can use it. For instance, if you are trying to define a product or electronic product, you could define some enum like this. Enum, give it some name, right? It could be, how about it's a pad, it's a laptop, it's a desktop, it's HPC, blah, 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 right? You can give it a name called a type, right? This is a typical way people use a enum, right? For this one, for example, if it's a pad, you will do something. If it's a laptop, you will do different things. For example, running different benchmarks so that you can get the score, right? It's typically what you can do. Instead of using some integers to specify the type, you could use enum to specify the type, right? So that is something you can do using enum, right? In the future, if you designing a class or inheritance class, you will see enum will be used. But in the past few weeks, we haven't used enum for many weeks. All right, so This one, you don't have to fully understand the code. You don't have to fully understand how union works in your memory. It doesn't matter. You just remember union only contains one member. That's all you need. All right. So when we're defining a class, right? So what is a class first? A class is a type, right? So there are two concepts people typically getting confused. One is class, one is object. One is object. So object is like a variable. So let's see here. This one is a class. It's a type. It's a class, right? The best object is a object. So we only have best product.name. We don't have product class.name, right? Best product class, as you can see, product class, it defines a name, right? It defines a name, but it don't have a name. But the object itself, best product, it contains a name. Right? How to understand it? So the class is like a type, right? It's like you can think of class as human, all humans, all people. An object is like an individual person, right? Each individual person. So human don't have a name, right? But each individual person has a name. So that's the difference. So when you are trying to access the members belongs to one object, It's not belonging to the class. In the future, we will learn some common properties for the class. But for now, we just remember these members are belonging to each individual object, right? A name belongs to individual person instead of belonging to the human. So that's the difference between a class and an object, right? So in object-oriented programming, it's very important to distinguish these two concepts. And for every class, we need to specify an interface, right? Like the factor we have used. What are the interface? The interface like pushback. Pushback is an interface. It's a function. It's a function that's belonging to this class, but it can be used by the outside. All right, this is called interface. Interface is the function belonging to that specific class, but it can be used by the outside, right? Like interface for human, right? Human can eat, can walk, right? These are called the public interface. And we call them member functions. It's exactly the same as functions. It's almost identical to functions, right? Everything you learn about functions can be just moved here. The only difference is it's a member functions. It's just belongs to this class. So for instance, if we are trying to create the interface for your product, you can say, okay, how about I want to make a product? How about I want to read in a product? How about I want to compare to product, right? How about I'm printing a product? Let's do the print first. Let's see. So first, I want to show you how to make identical. Let me move this part and make it private, right? And this one should be private. So in encapsulation, we are trying to protect all the members that is belonging to your class. It's like the, let me give you an example. It's like your factor, right? It's like your factor of int. So a typical member of your factor is size. So factor contains something called size. But it didn't allow you to assign size to your factor. It didn't allow you to immediately assigning a size to your factor. All right. That is because a factor wants to protect its member size. Similarly, in our product, when we are defining our class product, we want to protect our data like name, price, and the score. We don't want other people to immediately modify them. We don't allow them to do that. So this one, we are trying to make them private, right? And we need some public interface like the print. We are trying to write some function that can print our product, like the, let me make it a void. Similar here. And in here, we can say, how can we print this product, right? Let's see, copy here, copy this print function here. We are trying to output the name, output the price, output the score. Now, as you can see, there's no error message when I'm trying to output the name. There's no error message when I'm trying to output the name, right? Even the name is a private one. I can access name immediately. I can assign name. I can assign name to anything, right? String, right? It's totally valid because the private means no one outside of your class should be able to access them. But your print function belongs to this class. It is your member. It is your member of the class. So they will be able to access your private part, right? And how can we use it? This is how we use it, right? Instead of see out the whole thing, we can call it best product.print, right? This is how you can call the function. So it's not a print function. It's not a global print function. It's the print function inside your class. It belongs to this class, right? Product class. It's not a global print function. So if it's a global print function, they cannot access your private members. But if it's a print function belonging to your own class, it can access your private members. So that's the access control. Only you can design who will be able to access your data. No one else can access the data. So that is the benefit part. So let me make all the things work. Let me see. Because this one is a private, you cannot do it. Let me see, how can I change it? All right, so anyway, I need to comment them out. Yeah, it's weird, it's tedious. Yeah, it's this function. I don't need this function. I can immediately removing them. Let me remove it. Best product. And how about here? Yeah, I need to comment them out. That's called a test class. Right, let's run it. Wait a minute. This one's not needed. Delete them. Product class. All right, so now it's working, right? In our function, we first define a product object. It's defining an object called best product. And this object is calling the print function. Let's put a this one here. A breakpoint in here, as you can see, we are now in this function, in this function call, right? And let's run it. When you run it, it will jump into the print function inside your class. And because you are calling this one by best product, so this name belongs to best product, right? This name is best product.name. This price is best product.price. This score is best product.price. Who is calling me? This one is their members, right? This one, because this function belongs to one object. Only an object can call it. So these are the members for that object. So that's this part. So for the print, and also we could add in something like const. It seems sometimes weird, right? Put a const at the end of your function definition. This const means I'm not changing the members of my object. So when best product is calling print function, if you put a const here, it means this print function will not change the members of my best product. So if I'm trying to assign name here, there will be some errors. There will be some errors because this guy is read-only because of this const. This const means I'm not allowing other people to change it. All right, so this is the const. And what we can also do is, this is containing the implementation inside our class definition, right? Sometimes people don't like that. What people will do is they will move this one outside, make this one. I'm just declaring there is such a function exists, right? The real implementation, I put it in somewhere else. I'm putting it to the outside. As you can see, this one is outside of my class definition. So in order to do that, if you write it in this way, you are defining a global print function. If you want to define the function just for the class, you use class name, column, right? This way you are trying to say, I'm defining the print function that is belonging to this class, right? You should use the product class, column, print. You are specifying this print function only belongs to this class. It's not a global print function. All right, so this one is, this is something that people typically write in a header file. It's just interfaces. People only need to know you are doing a print. They don't need to know how you implement, right? How you implement it could be a different file, but this one could be in a header file so that people only look at how you define this interface. So that's a good habit. So for a typical function like this, right? And we could also define some functions like the Boolean is better than another product class. We are defining another product P, right? So I'm using two consts here. How you return, it doesn't matter. Let me just return true, all right? Forget about why this one is returning true. I'm just making this function simple. All right, so as you can see, if you're trying to read this function, this const is something we have just mentioned, right? Like the print function. Whoever is calling me, I'm not changing your value. This const means I'm not changing P, right? I'm not changing the members of P. So how can we call it? This is the first one. We could have your next product, and we can call best product dot is better than next product, right? When this function calls, best product is the object calling this function, and this next product is the parameter assigning to P, right? Let me see, how can I make them fit? Yeah, so next product is assigning to the parameter P. And the best product is the one who is calling this function, right? So the first const says, the last const says, I'm not changing best product. So you cannot say name assigned to a string is not allowed because of this const. And you also cannot say p.name assigned as string. It's not allowed because of this const, right? If I'm moving this const, this one is valid. If I'm moving this const, this one is valid. This one is valid, but this one is not valid, right? You can try this one and see how it works. Anyway, this one and the next one, they are exactly the same, right? Just some function calls. Just some functions. It will be almost identical to what we have learned. So there will be very complex thing is constructor. So we have something called a constructor. These are something you should be able to understand. So as you can see, if we compare this function versus this function, right? This is the function. The difference are I don't have any return type, right? I'm not returning anything. I don't have a return type, but for print, you have a void return type. It's better than has a Boolean return type. But for this constructor, it don't have a return type. And also, the name has to be exactly the same as the class name. If you are a product class, my name is product class. This one is called constructor. It is used to initialize your data. For instance, you can say name equals to test, price equals to 100, and the score equals to 0, right? You can initialize some data in here. It's typically used for initialize your members. So people have confusion because they don't know when this function is called. This function is called inherently in here. When you are trying to create one object, it's calling the constructor function. It's calling the constructor function like this one. If you follow this step, right now I'm in this line. If I'm step in, you can see it's step into my constructor. Right? It's a step into my constructor, and it is assigning the members of them one by one, right? One by one, then it will jump out here. After this one is done, after this line is executed, right? As you can see here, it seems like we are not giving some initial values to best product, right? It seems like there should be no initial value for it. But indeed, when this one is done, there are some initial values. First, the name is test, price is 100, and the score is 0, which means whenever I'm creating one object, it will immediately calling my constructor function, using this function to initialize my data. Right? So when we talk about the variables, we said whenever we say int I, our compiler, our system will create one space in here. It's for int, right? But we don't initialize some data in here. It can be some random data. And also similar here, if we're defining a product class called product, right? Then this guy, the compiler will give you some space. For example, this is the space for your product. And it contains name, price, and the score. It will separate them into different parts. First one string, second one double, last one integer, right? They will separate them. But for now, there will be no initial values, right? Remember, when we don't have the constructor functions, these values are random. And when they are there, then it's calling this function, right? Then it's calling this function. It will call this function immediately. You don't have to call this. It will be called by the compiler, all right? So it will assign tester to here. It will assign 100 to here, and it will assign 0 to here, right? Then you are creating, this object is done, right? It's created. So that is the basic process. So you have to understand this one, right? The constructor. Let me do this again. If I don't have the constructor, right? So when you run it in here and execute it, there will be some random numbers, right? You never seen this one before. It's just some random numbers. But if you have your constructor defined, it will immediately call your constructor. But this line seems not a function call, right? It's not a function call. It's creating one object. Creating one object will inherently calling that function and initialize your data to be test 100 0, right? So this is your constructor function. And similar to the print function, you could also write your constructor function to the outside. You could write this function to the outside and make this one a semicolon. All right. And this is the function name, right? This is the function name. We said that this function belongs to a class. It has to do something similar to the print function. We should do something like this. Now this is the constructor function defined outside of your class. All right, let's see whether this one will jump to here, right? Let's run it. And then run it, right? As you can see, this, when you're creating one object in here, it is jumping to the implementation in here, right? It's trying to initialize all these variables. And yeah, then it will be done. All right, so that is basic stuff about the constructors. Any questions about it? About constructor? Yes, question. It is public. Is it public? Indeed, everything, right? So as you can see here, right, the class definition is public. Right? Class definition is public. So you are trying to define this public interface, right? You can also make them private. It's also fine. Let's see, make this one a private member. You can also make them to the outside. Let's move this one down. And make it product, column. Now this one is the function. And we can make this one a semicolon, right? It's also valid. Whether this function is a public or private is defined by which section you are in the class definition. Right? If it says it's a private, if it's a private member function, then this one is a private one. You don't have to specify whether this one is private or public again, right? It is specified in here. So people typically read this part to understand which are the public interface, which are the private members. All right, so if it's private, it means no one can call this function, right? And you will see there will be some error here because the it's better than is a private member, so you cannot call it. You cannot call it. This one is because it's private, right? Any more questions? No? All right, so let's do this. Move this one back to public. All right, let me copy this code to here so that I don't forget. All right. So we say every class should have some public interface, right? You are asking user to use your class. If you don't have any public interface, then no one can use your class, right? It doesn't make sense. So here is a typical way. We are trying to write a class header. In the future, we learn how to make this one a separate file called .h header file. And this one could be just in one header file. And as you can see, a class, its members are grouped into public and private sections, right? And in the future, we will learn something about protected when we learn about inheritance. But forget about that one for now. Just learn public and private. It doesn't say it has to be functions or data, right? But typically, all the data are private. In most cases, data are private. And we have some functions that's public, some functions that's private. So that is a typical way we do. And we have our constructor, right? The same name as your class name. And it is typically used to initialize your data. But indeed, you can do anything here, right? It's just a function. You can do arbitrary things here. but it's just a suggestion. Only initialize your data inside your constructor function, right? Otherwise, it doesn't make sense. So when there's no parameters, here, it's called the default constructor. It's called the default one. And the default one can be called in this way, right? Whenever you are creating one new object, you are calling this default constructor, And in next class, we will learn you could also put some parameters here. Then that one is no longer your default constructor. So default constructor is the one with no parameters. And it can be called like this, right? And most of the class, whenever you define it, it has a default constructor. You don't have to write it, right? Here I write it. You don't have to write it. Even you don't write it, when you are trying to initialize or create a new object, it will call some default constructor. That default constructor is created by the compiler. Compiler will create a default constructor for you. And also, in this way, right, it seems like you never write any constructor. And other people might think, did you forget it? Or are you intentionally asking the compiler to generate it? So people designed some way to say, this one equals to default. It is telling others that I'm not forgetting, right? I'm not forgetting a constructor, right? I'm not because I forget to write a constructor. It's because I want the compiler to generate one, right? Then I can write it in this way, equals default. I'm asking the compiler to generate it. Writing this line or not writing this line, the effects are exactly the same. The only difference is I'm explicitly telling others I'm not forgetting. I'm just asking the compiler to generate it, right? I'm just asking the compiler to generate the constructor for me. So this one or without this one, they are exactly the same, right? But most of the time when you are collaborating with others, it's a good practice, right? Explicitly telling others what you are doing. So this is something that a good habit would do. Let me see. So we have a bunch of member functions, right? Such as we have write the print or is better than, because they are just accessing data. Print, right? Just accessing data. Sometimes we call them accessor. And we could have something also called a mutator. We are trying to modify the data inside our functions. So let's see. Yeah, they make sense. Let's use some examples here. What are the typical accessor? Typical accessor would be std string get name const return name. This is a typical accessor, right? You could also say double get price const return price, right? You can do the same for the score, right? You can do the same for the get score, int get score const return score, right? These are a typical way to write an accessor, right? Because everything in here is private. Other people cannot directly say best product dot name. They cannot say that, but they can say best product dot get name, right? So it's like the factors, right? Instead of saying factor dot size equals to no, instead of print factor dot size, right? It's not valid. We typically say factor dot size, right? What's the difference? The first one is you are trying to access its private member. It's not allowed. You cannot do that because it's private. But for this one, you are trying to call a public interface that will return a size for you, right? It's like print product dot price, right? Product dot price, it's invalid. But if you say dot get price, it's valid, right? So these are the way people typically write. It's called accessor. You are trying to access its private members, right? Using some public interface. And this one are you are trying to access their private members, right? The reason people do that is because they don't want people to immediately modify the size, right? Like 10 or like the 100, right? It's not allowed. But what you can do is if you say you want other people to modify it, then what you can do is, how about I generate a function that is says set price. You can say have an integer, no, double new price. What you can do is assigning new price to my price, right? So instead of immediately modify my price, I should call something like the product.new set price 100. All right. So I'm not allowing you to immediately modify my data, but because I'm opening one public interface, I'm opening one public interface here, so you can set price by calling this function, right? You can set the price by calling this function. So what's the benefit of this, right? You would think this one is much easier, right? It's much easier. Writing it or reading it is much easier. But the key idea is we said encapsulation, right? You want to protect some data. For some of the data, you think, okay, the user might change it, but for some of them, you don't have a set. For example, I don't want people to set my score. So you cannot set score, right? So you cannot set score because I only allow you to set price. You're not allowed to set name or set score. These are the access control. Other people can only set your price, for instance, right? So that will be good. And also, for instance, if you say get a score, right? You could maybe not just returning score. You can, for example, you can run some benchmarks to return the performance of your device, right? You can do something like that. So that is, we call them, this one are called accessor, right? Just read the members. This one are the mutator. You're trying to modify the members of your object. Because all of them are belonging to the class, they will be able to access their private members. But if it's outside, you cannot immediately access them, right? So that's the key idea. And we said this one, we call it encapsulation, right? We control who can access which part. We control who can set which part. These are very important. And the only constructors and the member functions can access the private part. And you can try this one, right? If you are trying to the name immediately see out, there will be some errors. And the next one, let's talk about another benefit of using encapsulation. Using this example, it's called a time class. All right, let's see where can we put it? Maybe after them. Yeah, anyway. In here, all right, so let's say we have a class. We want to define a class, which is called time. Let me copy that. Is there anything I can copy? Yeah. Let them be public. Let them be private. Right. As you can see in my time class, I have a constructor. Let me remove this one. Maybe next class we will talk about it. We allow some of the public interface, right? This bunch of get are just returning, for example, the seconds, the minutes, the hours, and let me remove this one. All right, so there could be different implementations. Let me have two types of implementations. First one, time. Second one, time two. All right. What you can do is, for instance, you can say, okay, how about I returning the hours and the minutes and the seconds, right? So using this way, what you can do is, for instance, you can return return the second, right? In here, you can say return minutes, right? Something like that. Or you can have another implementation, right? Your implementation details could be different. You could just remember the seconds, right? So how you can returning the seconds, you can say return seconds mod 60. This would be my seconds, right? Then in here, you can say return seconds divided by 60, then mod 60. This could be my minutes, right? So your implementation details don't have to be, people don't have to understand how you implement your things. The only thing they are trying to use is your public interface, right? As long as your public interface are exactly the same. Either you change your implementation in this way or this way, it doesn't matter, right? How about the add seconds, right? Add seconds, it could be, here maybe a little bit complex, but here just a seconds plus s, right? If I want to add some seconds to my current seconds, this one becomes this. But this one you need to be a little tedious, right? You need the seconds to plus equal s, then seconds equals to seconds mod 60, right? Then blah, blah, blah. You need to do many more things, right? So maybe you should do minutes first. So minutes plus equal seconds divided by 60, and so on. Right. So regarding the how we implement this are decided by the programmers, right? As you are designing this class, you can implement it in different ways, right? Using this way to implement or using this way to implement, it really doesn't matter. So, and what's the benefit of using this? For example, when people are trying, if people, for instance, if we allow the hours to be public, and when people says, okay, I want to add 6 hours, they immediately add it. But for instance, if your current time is 19, right? And after adding 6, the time format becomes 25. It becomes an invalid format, right? So if you allow the user to modify your data, it could be any random number. You cannot control what is the output of your data. So that will be very complex. But instead, if we only allow the user to use the add seconds, right? It can add 6 hours times 60 minutes times 60 seconds, right? The only public interface they can call is this one. They cannot immediately modify my data so that we can control the format, control the values, everything we can control, all right? So that is the one idea about encapsulation. We are trying to control how the user could use our class. And in the future, we will learn something called a friend. We are defining a friend of me so that they can access my private part. But that will be many, many classes later. And we say encapsulation allows us to change the implementation of your details, right? Like the time. Whether you whether you prefer the first implementation or you prefer the second implementation, it doesn't matter, right? As long as the user use this public interface, they will get exactly the same result. So that is the idea about encapsulation. You are trying to implement, you are trying to separate your interface versus your implementation. So as long as your public interface are correct, then it doesn't matter how you implement everything. And they don't need to change their code, right? If they said add 6 hours, they still use this code. They don't need to change anything. So we can, right? So we can implement our public, not public, our member functions in this way, right? When it's outside, when the read function is outside of your class definition, we need the class name, column, the function name, right? This is how we define a typical function, right? It's very similar to what we have learned previous. The only difference is adding the class name. It's very similar to the namespace, right? std column, but it's indeed not namespace. It's not namespace. It's just saying this one belongs to this class. Okay. So this is how we can call a function, right? We use an object. It's not a class. It's an object. Then the function name, right? like the next product dot read, it's an object calling a function. And then we put a constant here to specify we are not changing the members, right? The name, the price, the score, we are not changing it. If we don't want to change it, we put a constant at the end of your function. We are not changing the members. And when people calling your function print, by reading the interface itself, they know you will not modify my data. So that is a guarantee, right? That is a guarantee you are not modifying my data. And another maybe concept topic is about there are some implicit parameters there. This one is called this. This is a pointer pointing to current object. Is a pointer pointing to current object. Let's do this. Let me move this one down so we can still see the code. All right, in here, in the print function, right? You can write it in this way, or you can also write in, let me comment this out. It's called this name, this price, and this score. All right, it's better than, let's look at this one. Right, how about this print function? And this is best product calling this print function. Let's see how it goes. When you come to here, first pay attention to the best product. Right, best product is this guy, and does it have an address? No, it's not showing the address. Anyway, let me see, how can I print this address? Is it something we can click? No, it's not a point. Anyway, let's get into it. And now this is pointing to, this is an address. This is an address. It contains the address for your best product. It contains this address for your best product. Whoever is calling me, this one is pointing to the position of your object, right? Then this name is best product's name. This price is best product's price. And if you look at this, the type is a pointer, right? It's a pointer pointing to a product class, right? Like the, maybe we can discuss more in our pointer class. Yeah, at least for now, just know it's there, all right? Just know it's there, and you don't have to fully understand it. And this is how we can use a pointer and getting these members using arrows. It is exactly the same as we first getting the value, then calling a dot. But anyway, we will discuss this one when we go to the pointer class. So this one is also something you can do. But let me forget about this one. Let's just do this version for now. All right, so this is the same as in Python. If you know in the future, Python has something always called self name, self's members, like that. So similar, right? So in the future, when you learn Python, you will know the self. Anyway, let's forget about this because it's a pointer, right? We will learn pointer in the future. And this one, we call it implicit because it's not in your parameter list, right? It's not in your parameter list. And explicit parameter, we're calling this B. This one is in your parameter list. So this one is called explicit, right? We explicitly saying this is the parameter. But for this, it's not a parameter, but we could use it